We're going to check out some math operations in this program. So we'll give the project the name Arithmetic Operations. That's the name of the project. And we'll get ourselves a class, making sure we are in the correct source folder. And I'll call the class Math Stuff, taking a free public static void main string args. Do some documentation at the top with my name, the date, and the program.java, the name of the class. And this is going to be learning about arithmetic operators or arithmetic operators in Java. I'm also going to document these ending braces very quickly here at the start. Math Stuff is the name of the class, and main at the end of the main method. We'll look at adding, subtracting, multiplying, and dividing. We'll start with some addition. I'll declare glazed donuts as an integer variable with int, and I'll just make up an addition problem. You can make up whatever you want, and I'll display the answer. Glazed donuts is 9 plus 12, and hopefully that will add up correctly. It does. Glazed donuts, 21. For subtraction, I'll use bear claws. So make up a subtraction problem for bear claws. I'll go with 25 minus 18 and check it out. We get 7, just as I was expecting. Maybe it's because I ate 18 bear claws. Chocolate donuts. I'll use that for a multiplication problem. So make up a multiplication problem. I'll have 17 times 11, like 17 boxes of 11 donuts. I guess it would make more sense to have 12 for a dozen, but anyway, 17 times 11 is in fact 187, which is plenty of chocolate donuts. Now let's go to some division with powdered donuts. I'm going to make up a division problem that I know the answer is going to turn out very nice and neatly, with two numbers where the divisor does go in without any remainder. So I'm going to use 75 divided by 3. 3 does go into 75, and we get 25. It's what I was expecting. Let's try some more division, this time with cinnamon donuts. This time I will take two numbers, and I know the answer will end up as like a decimal or a fraction. So 19 does not go into 374 evenly. Let's see what we get. 19. But 19 times 19 is not 374. What's going on here? In fact, 19 times 19 is 361. That's kind of not even close to 374. Well, what is 374 divided by 19? 19.68421052631579. So that 19, that's not even rounded. It actually just gave us the 19 and that's it. Well, let's try this. Let's make a double variable. I'll call it DBL cinnamon donuts. And so then I'll try to divide and put this answer into cinnamon donuts. Maybe this will help. And I'll display what DBL cinnamon donuts is. Let's run it and find out. Let's see if we can get that nice long decimal. Well, we got a decimal, but it's 19.0. It's the same answer we got before, just with a 0.0 at the end, because it's a double. That did not help the situation. Boy, what will we try next? Well, here's the deal. If you want a double answer when you divide, one of those operands has to be a double. And that was the problem. Both the numbers that we were using to divide were integers. When you divide an integer by an integer in Java, your answer will always be an integer. So if I do 374.7 divided by 19, that 374.7 is a double. And now we do get a double answer. Well, okay, I wanted 374. I'll make it 374.0. That is a double. And now we get the answer that matches what we saw in the calculator. So that's one way to make sure that you get a double answer if that's what you want. Because otherwise, when you divide two integers, you're going to get an integer answer. And it will just be the integer part. There won't be any rounding up. Let's look at this a little further with apple fritters. We can use casting. So we'll use the two integers again, but cast one of them as a double. It's like being in a play. You're still you, but you're cast as another thing in the play. Well, in this example here, 7 is an integer, but it's cast as a double. So it acts like it's a double. Let's see if this will help us out for apple fritters. Apple fritters is a double. And it does work out because 7 was cast as a double. It doesn't matter which one you do that to. You can pause the program and try it with the 207 or whatever problem you chose to use. But it's probably a mistake you'll make somewhere along the way. You always have to remember that anytime you divide two integers, you're going to get an integer answer. If you want a double answer, one of the operands has to be a double. Let's mess with some donut holes now and look at modulus division, which is the remainder. In Visual Basic, we used mod. Here we're going to use the percent sign. So donut holes will equal 94, and then the percent sign, 6. So if we're going to put maybe 6 donut holes in a bag, and we've got 94 donut holes, this will tell us how many donut holes will be left over. And there are 4 donut holes left over. 6 goes into 94 15 times. We would get that if we did 94 divided by 6. And there are 4 donut holes left over. I think I will eat them. I would hate them to go to waste. So again, I'm going to type a reminder here. Integer divided by integer always gives you an integer answer. That's integer division that we saw in Visual Basic, if you studied that, when we had the slash going the other direction. And again, it doesn't round, it just gives you the integer part of the answer. If you want the remainder, use the percent sign. Next, exponents. I'll declare exponent answer as a double, and it will equal capital M, math.pow. And as you can see here, it takes 2 arguments. We're going to have the base first, and then the exponent. Use whatever you want. I'll go 2 to the 9th power. The caret that we used in Visual Basic doesn't work in Java. Let's check out the answer that we get. There it is, 512. And again, it's a double, so it stores it as 512.0. Square roots. That's capital M for math.sqrt. And you can put your number inside there. I'll use a perfect square, but you can try a number that is not a perfect square. You will get a double for an answer. We'll check this out. I used 49, and the square root of 49 is 7, and you see there's the answer, 7.0, because again, this is a double as a result. The math.square root method, or SQRT method, returns a double. Math.pow also returns a double. Now let's check out some combined operations. I'll start with x as an integer, or int, and I'll set it equal to 12. We'll display that so we clearly see that that is the initial value of x. There it is, x is 12. If we use x plus equals something, you make up whatever you want, I'll use 11. It will add 11 to the value that already was inside x. So now x is 23. If we do minus equals, pick whatever value you like. I'll do x minus equals 17. So whatever the value x was at first here, you subtract 17, and now that's what x is. It's going to be 6. There it is, because it was 23. If we do x times equals 10, again, this is like x equals x times 10. X is 60. If you studied Visual Basic, you saw much of this in that class. X divided by equals 5, it's going to take what x was and divide it by 5 and store that in x. It's like x equals x divided by 5. So 60 divided by 5 is 12, and now that's what x equals. We can do this with modulus also. So the remainder, when you divide 12 by 5, well, that's probably going to be 2, because 5 goes into 12 2 times with a remainder of 2.